Test on Tuesday. We have a lot to go over today and Monday to get ready for the test. Here's what I want everybody to do. Everybody, please open your books to page. Wrong way. 300. Some of this is going to feel like, oh, that was so long ago. Okay, first thing you got to be able to do on the test, there will be questions that say, is this linear or not? Now, what's the word linear mean? Straight line. So, graphically, I think that's super easy. So, yes, if I give you a test question and say, which of these is linear? 3. That's easy, right? The only one that's a straight line, 3. The harder question is if I give you something like this. Is this linear?
Yes.
Why?
Because the numbers correlate with each other.
How do you tell if something like this, if I give you a bunch of points, how do you tell if it's linear? What are you looking for? Constant increase or constant decrease, right? So, but you can't just look at the x's or you can't just look at the y's. You have to look at, well, that went up 1. That went up 1. Uh-oh, that went up 2. That's a problem, right? What happened here? It went up 2. So this increase is actually up 2 over 1, right? This increase, again, is up 2 over 1. This one... Sorry, I said that backwards. Yeah, sorry, y's go on top. Up 2 over 1, up 2 over 1. This one went up 4, but it went over 2. Is this all the same thing? Yes. So as long as it's still going to be the same increase. Now, I could be, you might run into something like this that goes 1, 2, 3, 4, and go, oh, that looks like linear. And this goes 2, 2. Is this going to be linear? If this is the x and this is the y, well, what's my y increase? 0, isn't it? Right? So you got to be careful with those. You're looking for constant increase, right? Or constant decrease. So be careful with those. And what I mean is, everybody look on page 300. Look at number 18 and 19. I will tell you, one of those is linear, one is not. So just look at 18. Look at the x's. This goes up 3. Goes up 3, goes up 3, goes up 3. That's good, right? What's the x doing? It went up 1, and then it went up 1, but then it went up 2, right? So is 18 going to be linear? No. What about 19? That one is yes, because the x goes up 1, goes up 1, goes up 1, goes up 1. And then the y goes up 1, 1, 1, 1, 1. So yes, that is going to be, are we good with those? Determining, is it linear, is it not? So there's 3 types of questions you got to be ready for in the test. Graphically, set of points like that, and equations. Is this linear? What kind of things do we look for that make it not linear? This is linear, yes. What kind of things make it not linear? Exponents. Y equals 2x squared. Absolute values. Square roots. Right? Also, you got to be careful when you see something like 2xy equals 5. Are you allowed to multiply x and y together? No. And that's important because on a test, I might give you this. One of these two is linear, one is not. Why the top one? When you butterfly, what do you get? 4y equals 5x. Are you multiplying the x and the y together? No. That one's a yes. But this one, when I butterfly, I get 20 equals x times y. Is this going to be linear? No. Are we good with those? So section 1. Is it linear? Is it not linear? We're good there. Yes? Section 2. Everybody look at page 306, please. I feel like you guys are really good at this now. How do you find the x and the y-intercept? Make y 0. So this one, the y goes away. You just got 2x equals 20. So x equals 10. How do you find the y-intercept? Make the x 0. So 4y equals 20. So y is going to equal 5. I feel like you guys are really good at that stuff now. Yes? Now, a question for you. And be careful with these, because this will be on the test. Remember, we did some story problems with these, where I said, this is the equation of me running a 5K. Okay? What do the two intercepts represent? When I graph this, and I say my x-intercept is 10, my y-intercept was 5. When I graph that, what does that mean? Like, what do these 2 points represent? What does the y-intercept generally talk about? That's the starting point, right? I still got 5 kilometers to go, right? What's the x-intercept represent? The ending point. So in this case, it took me probably more like 10 hours instead of 10 minutes. But yeah, get the idea? So there will be a question like this on the test. There will be a story problem type of thing that'll ask you, what does the x-intercept represent? Okay? Now, it could be starting point and ending point. It could be like maybe I say I have 2 apples and 4 oranges, and together, the price is $20, whatever. Or the apples cost $2 a piece, the oranges cost $4 a piece. I got to pay $20. The x-intercept would be if I buy 0 apples. Does that make sense? And then the y-intercept would be if I buy 0 apples. The x-intercept would be if I bought no oranges and all apples. Does that kind of make sense too? So, are we good with that idea of what they kind of mean? I can guarantee you, I just made the test the other day. There is a question kind of like that on the test. Are we good with those? Okay. Any other questions on x, y intercepts? Are we good with those? Okay, go to section 3. Now we start talking about slope. How do you find slope? There's going to be two types of questions. You're going to have questions in graph form, where I ask you to find the slope of that line. And yes, I'll probably give you, so it's easy to find so we don't make the mistakes, I'll say use that point and this point. I might even tell you that this is at 2, 1, and this is over here at 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I give you this question, ask you for the slope, what's the easy way? You could use the slope formula and go 10 minus 1 over 5 minus 2, which would be 9 over 3, which reduces to 3, right? Or you could just kind of draw and find the rise and the run, and then write 9 over 3 and do it that way as well. Do I care which method you use to find the slope there? Be able to find the slope. Okay? There will be questions where I give it to you in graph form and ask you for the slope. There will also be questions where all I do is I give you points. So I don't draw it for you, I just give you these. So you're going to want to use the slope formula. But I feel like we're pretty good with those now. Yes? There's one I feel like I forgot because I'm thinking of a problem. It's just not in that section. Was that? What section was that from? That was in section. What section do we do domain in? Because I know there's a couple questions like that on this test. And I wanted to talk about it. It wasn't the slope. It wasn't the y equals mx plus b. All right, so anyway, here's the type of questions I want to talk about. On the test, there's going to be a couple questions where I give you a scenario. And I say, my car gets $20 miles a gallon. The amount of, if I fill up, it can go 400 miles. And it gets 25 miles per gallon, so I can subtract that. Here's the equation. If I ask you for the domain, in this scenario, would that be a continuous graph or a discrete graph? Why continuous? You can stop anytime you want, right? You can stop at 1/10 of a mile or 2/10 or 3/10 of a mile. So, can you drive negatively? Okay, but can you use negative gas? If I drive backwards, do I get more gas in my car? It'd be nice, wouldn't it? But no. So, can I use negative numbers in this case? No. So, my domain would be all real numbers, right? That are bigger than 0. Anything bigger than 0. Does that make sense? Now, at the same time, if I give you a different scenario and say, I'm going on vacation and I'm going to rent a car and the price is $50 plus $30 per day. So there's my equation. What's my domain now? Is it all real numbers? Is it negative numbers? Can I pay for negative days? No. Would this be discrete or continuous? So this is me renting a car. X is the number of days. Y discrete. You can't, they're not going to let you rent it for a quarter of a day. You know, this is where my domain would just be 0 days, 1 day, 2 day, 3 day, and so on. Like you're not going to have a tenth of a day, 2/10 of a day, 3/10 of a day. Does that make sense? There are questions on the test like this, and you have to be able to look at the scenario and decide, why is it discrete? Why is it continuous? And then if it's discrete, I'm only going to get charged for 0 days, 1 day, 2 day, 3 day. Both of these I have to eliminate negative numbers, right? Because I can't, they're not going to let me pay for negative 5 days. That'd be pretty sweet. That means they owe me money. This one, I can't drive negative. I can't get negative gas. So that's out. But I can stop at 1/10 of a mile, 2/10 of a mile, right? Easy? All right, so we're good with those? And then we did slope. Direct variation. Do you guys remember? Do you remember the equation for direct variation? It's just y equals kx. Basically, it's y equals mx plus b, but what's missing? The b, the constant. Okay? So let me give you a few equations. Let's say I give you all three of these. Only one of these is a direct, only one of these is not a direct variation. Which is the only one that has a number that's not connected to an x or a y? That has a constant. What's the only number that if I tried to put it in like y equals mx plus b, it would have a b value? Y. What part of this makes it not a direct variation? The 12. That 12 is not connected to an x or a y. This one is not direct variation because of that 12. This one, if I solve for y, I'd have 3y equals negative 4x. There's no b. Yes, I would divide by 3, but there's still no b, right? So that is a direct variation. This one, when I do the same thing, that 12 is going to kind of give us the b. The 12 isn't the b, but does that make sense? This one, when I butterfly, I would get 10y equals 2x. There's no constant. There's no other number that doesn't have an x or a y attached to it, right? That means this would be the one that's not a direct variation. Are we good with those? There is a test question just like this, where I will give you this, I will give you this, and ask you which one is not a direct variation. What's the only thing you have to look for? Look for a number like this that's not attached to an x or a y. That means that would help us find the b value. Good? If I give you a set of points, like everybody look at page 329. Everybody look at page 329. Here's basically the types of questions on the test. Look at 10 through 14, the bottom of page 329. Is 10 direct variation? Yes. Is 11 direct variation? Yes. Is 12 direct variation? Why not? Because of that minus 12. The 12 makes it not a direct variation. Now, How about number 14? What if I give you a set of points? How do you know if negative 6, 3, 12, and then 4, negative 2, negative 8? How do you know if that's direct variation? Remember, direct variation, you should be able to do a butterfly. Here's the easy way. Is negative 6 is to 4 the same as 3 is to negative 2? If you butterfly that, what do you get? 12 equals, oh, that worked. Try this one. 3 is to negative 2 as 12 is to negative 8. Negative 24, negative 24. Does it work? Yes. If I give you a set of points, just check the butterfly. Okay? Good? And then also remember the questions like, turn the page, question 15, where I say if y varies directly with x, and y is 8 when x is negative 32, find y when x is 64. How do you do those? Just set up a proportion, right? All right. Everybody look at page 368. 368. This is the chapter review that we're going to start working through. This is going to be due the day of the test. Okay? Online, guys, this is just look on the assignments and you'll know what numbers you have to do. Okay? So start working through those.